So this is the graph. Everyone try to understand. This is the graph, some graph. You can take whatever you want. This is the graph. I will give numbers also. 1 here, 2 here, 3 here, 4 here, 5. There are 5 vertices. So this is a connected graph because you can go from one place to another place easily. So it is a connected graph. Now give answer to me. In this connected graph, by deleting which vertex, graph become disconnected. If you delete 3 together with its edges, graph become disconnected. So this right, then vertex 3 is called articulation point. By deleting any person together with its edges. So see this one, 3 gone together the edges. Then graph become disconnected. Then right, then I can say that 3 is articulation point. So vertex 3 is articulation point. What about 1? If you delete 1, together their edges. So I think 1 is not articulation, 2 not. So 1, 2, 1, 2, 4, 5 is articulation point? No. Only 3 is articulation point. Now some people are asking, sir, what about this graph, sir? By deleting any vertex together with its edges, graph become disconnected. Then it is called articulation point. Now see in this graph, if you delete 1, no problem. Delete 1 together their edges, no problem. Delete 2 together their edges, no problem. Delete 3 together their edges, no problem. Delete 4 together their edges, no problem. So no articulation point. No articulation point. No articulation point. In the previous one, 3 is the articulation point. Here, no one is articulation point. A graph where no articulation point is there, that is called as bi-connected component. That is called as bi-connected component. It's not our goal, but just casually I'm saying. In the given graph, no articulation point. It is a bi-connected component. So remember that, right? It's not our goal. Our goal is in the given graph, how many articulation points are there? We have to find out. So I'm going to do within few minutes. I'm going to do within few minutes. I will give the nice algorithm also. Let's move to the problem further. How to do that? How to find out articulation points in the given graph? How to find out what the approach? Right? See this. In this graph, understand one small line. This is the graph issue. This is the graph issue. 1, 2, 3, 4, 5. In this graph, you want to identify how many articulation points are there. In this graph, how many articulation points are there? You want to find out. One simplest way is delete 1. Careful, delete 1 together. Delete 1 together. Their edges. Graph become disconnected. No. So delete 1. Delete 1. After deleting 1. First delete 1. After deleting 1, just apply, just visit the graph. If you can get all the people. After deleting 1, you start at anywhere DFS or BFS. You start at anywhere DFS, BFS. You got all the people except this person. Yes, then it is not a articulation point. If you want to identify is articulation point or not, what you do is delete that one. Start the BFS algorithm, DFS algorithm from any node. Supposition that I want to check one is articulation point or not. Delete one together their edges. From 2 onwards, apply DFS or BFS. I got all. Right? I got all. That means one is not articulation point. Okay, fine. One is not articulation point. That is absolutely fine. Right? In the similar way, let me check. 2 is articulation point or not. Delete 2 together their edges. Afterwards, apply BFS or DFS. You got all the people? Yes. Except 2, I got all. So 2 also not articulation point. 2 is not, 1 is not. Let's go 5. So no problem. Let's go 4. Let's go 4. No problem. Let's go 3. By deleting 3 together their edges, graph become disconnected. See this one. I think you delete this, you delete this, you delete this, you delete this. See, there is no path to go from 2 to 1. So I think this is the articulation point. 1 not, 2 not, 5 not, 4 not, 3. 3 is articulation point. So what I mean to say is, delete every person, apply BFT or DFT. BFT or DFT will take V plus E time. One time BFT or one time DFT will take V plus E time. So for every vertex you have to do V plus E into V. This is the time complexity to find out number of articulation points, right? If adjacency list to remember, list this is. Adjacency matrix, right? It's a V square for BFS or DFS, like that V times you have to do, which will goes to the time complexity for adjacency matrix. For adjacency matrix like this, because you have to do V times of BFS or DFS. Another way of writing the same sentence, one more way. How? Right? V times BFS or V times DFS. So V times BFS, right? V into, if it is a list means first one, if it is a matrix means second one. This is also same story. V times of BFS or DFS. So V times of DFS, V times of BFS. If list V plus E will come. Right? If the matrix V square will come. Other than this, nothing. Right? So everywhere two choices. V into V square or V into V plus E. So like this. I hope everyone got it. This is the easiest way. Simple approach. Easy way. Apply V times of BFS or DFS. This is the one way. Right? I hope everyone got it. Now let's go to one more excellent way. You can solve this problem using DFS. One more approach. Best approach. Not easy approach, best approach. Using best approach, you can solve this problem. You may say that's a how, sir. How can I solve it? Some people are asking, how can you solve this less than that time? So I will give idea. Can you see this? Everyone try to understand. Everyone try to understand. 1, 2, 3. 1, 2, 3. 1, 2, 3. 4, 5, 6, 7. Yeah, it's a graph. This graph is, in this graph, how many articulation points are there? I want to calculate. Let's do manually first. In this graph, how many articulation points are there? 1 is not a articulation point, everyone. 2 also no. 3 is articulation point. 4 not. 5 also not. 6 is articulation point. 7 is not. I think 2 articulation points are there. 3 and 6. 3 and 6 are articulation points. Right. Now some people are asking, sir, how will you calculate? Using the best approach, how will you calculate? Right? Let me try this. So I am doing DFT. Using a DFT or a DFS, you can solve this problem with less time. One time DFT, you can solve this problem. One time DFT, you can solve this problem. Right? So some people are asking, sir, how, sir? Let me check. What you do is start from any vertex. Start from any vertex, apply DFT. Let me try starting from 3. Starting from 3, apply DFT. Remember, apply from any vertex DFT. I am starting from 3. Let me change the color also. I am starting from 3. DFT, everyone know. Adjacent people take only 1. So starting from 3, 3 adjacent is going to be 1 also, 2 also, 4 also, 5 also. Take any one, no objection. I will take 1. 3 adjacent is 1, 1 adjacent is 2. Because of no other possibility, backtrack. Next one, go to the 3 now. So 3 adjacent is now in the available people. 3 adjacent is actually 1, already done. 3 adjacent is 2, already done. 3 adjacent is 4. Let's go to 4. 4 adjacent is, right? 4 adjacent is 2 people are there, 5 or 6. So you take any one. I will take 5. 5 adjacent is, right? You can take any one. So I will go to 6. 6 adjacent is 7. Right? Now go back. So I think all people came. Simply, I have not done anything. I done the DFT. If anyone don't know DFT, please see the DFT algorithm. If you don't know DFT, please see the DFT algorithm. I started from three adjacent is 4 people. I took one first. After one, two. After two, no other possibility, backtrack. After three, right, afterwards I came back to three. From three, I went to four. Four to five. Five to six. Six to seven. There are many DFT sequences are possible. I done one. Remember, this is the DFT tree. I applied the DFT. Whatever I got, it is called DFT tree. It is a DFT tree. Whatever you got, that is called DFT tree. Now, in this DFT tree, please verify one small story. In this DFT tree, please verify one small story. What is that one? If the root contain more than one child, root contain two children. If root contains, see the first rule. In the DFT tree, if root contain, in the DFT tree, if root contain, observe everyone. In the DFT tree, root contain more than one child. More than one child. If root contain more than one child in the DFT tree, remember here, in the DFT tree, if root contain more than one child, then root is articulation point. If we want to check. So 3 is articulation point, you know very well. If root contain more than one child, then root is articulation point. That is the first rule. So if you want, you can check, sir. Some people are asking, sir, if root is containing more than one child, that is articulation point, okay. Then you got only one articulation point. So if not root, then some other story there. Second point. See the second point. Second point. So 3 is a root, yes. More than one child, yes. This is articulation point. Everyone know. Now see the second point. If not root, if root contain, suppose even the root contain only one child, it is not articulation point. If not root, then, so let's see this one. Is it root? Yes, first rule. Now go to the remaining people. I think remaining people, who is the next one? 3 is a root articulation point, already we got. I think one more articulation point is 6. Let's talk about 6. I want to check 6 is the articulation point or not. I want to check. Understand here. I want to verify 6 is the articulation point or not. What is the rule? If not root, so remember 6 is not a root. If not root, then see the rule. I am writing here. If not root. I want to check 6 is A. I want to check 6 is the articulation point or not. So ask first question. Are you root? If not root, then what you do is go to the sixth child. Is not a root, okay? Go to the sixth child. Sixth child is 7. Right? Can you help me now? From the 7 subtree. 6 child is 7. From the 7 or 7 subtree. If you want to verify someone who is not a root, articulation point or not, you want to verify. After constructing tree, go to that person first. Go to his child, right? Either his child or his child subtree. Means in this area. Go to the 6th child, or 6th child is 7. Go to 7 or 7 subtrees you go. From this area, do you have any back edge? Means from here, can you go to back? But remember, you have to go to back. Right? 6 ancestors. You want to check 6 is A, right? Articulation point or not. 6 children, from the 6 children, you have to go to 6 ancestors. 6 old people, back edge required. Can you see once? From the 7 in the original graph, from 7 children, are you able to go to back? Any back edge to 6 ancestor. No back edge means if you delete 6, definitely, right, 6 and 7 going to be disconnected. So I'm writing if not root, let's check. Then, so I will write in the professional way. I will write here in the professional way, so that you will get the clarity. If x is not root in DFT, if x is not root in DFT, if x is not root in DFT, then find child of x. So which may be, this is x. Then find child of x. It may be y. Then find child of x, which may be y. I am writing within the brackets. Then find child of x, which is y. Then from y subtree, y or y subtree. Then from y subtree, no baggage to x ancestors. That is the rule. If x is not root, yes, x is not root in the DFT tree, right? If x is not root in DFT tree, then find a child of x, which is y. Then from y subtree, no back edge to x ancestor. Means from here there is no way to go to ancestor. Means this also, this also, this also, like that. Right? That is the rule he is saying. Then if x is not root in DFT tree, then find child of x, which is y. Then from y subtree, right? Then from y subtree, no back edge to x ancestor. Then x is articulation point. These are the two rules. Other than that, nothing there. I think some people may be not getting, so I will give more clarity with the help of this example only. If you want, I will take one more example. Now see, I think I got to know two people are already articulation points. I got to know, everyone got clarity. Right? Let's see one more round. You will get more clarity. Can you see this? I want to check. Everyone observe. I want to check one is the articulation point or not. First one. Is it root? No. So second point you go. If it is not root, assume it is x. If it is not root, assume is x. Right? Is child is assume y. Can you help me now? In the DFT tree, from y to ancestor of x, any package. See the graph and check. Y means here I think it is 2. It is the 2. Can you go to the graph? And talk? Where is the 2? 2 here. 2 here. Right? From 2, any chance of going to 3? From 2, any chance of going to 3? Please let me know. Yes, there is a C. From 2 in the graph, you came like this. 3 to 1, 1 to 2, you came. I think you can go to 2 to 3. From y, there is a chance of going to, right, x ancestor 3. There is a chance. So back edge there. If back edge is there, if you delete this person also, no problem. Still you can connect like this in the graph. That is the reason. One is not articulation point. So see the second point. If x is not root in DFT tree, then find child of x, which is y. Then from y subtree, no back edge to x ancestor. Then x is a right articulation point. But here there is a back edge. See, no back edge. If back edge is there, it is not an articulation point. So one is not an articulation point. Some people are asking, sir, can you check 2 also? Let me check. Those people who are having little doubt also, they can see 2. They can see 2 now. Here, I am at here. So if you delete this person, below no one is there. So there is no chance of disconnectivity. If you delete one person, where is the disconnectivity? So there is no need to think about this. Right? Come here. 4. If you delete 4, what will happen? First step. 4 is a root? No. So second point you go. 4 is a root? No. Go to the second point. Okay. So this is assume that x. Right? So x child is y. Can you help in the original graph? From 5, any chance of going to 3? From 5, any chance of going to 3? Right? Because you are deleting x, which is 4. If you delete 4, any chance of going to previous? From 5, can you go to the 3? From 5, can you go to 3? So you came like this. 3, 4, and 5. I am at here. From 5, can you go to 3? Yes, you can go. From 5, can you go to 3? Yes, you can go. There is a back edge. So is not articulation point. So at 4 also not. Some people are, what about 5? Do the same story. If anyone having small doubt also, right, you can comment in the comment section. I'm going to help. Some people are asking, sir, what about this? Is it true? No. Second point. Assume it is x. The child is y. From y, can you go to 4? Right? From 6, can you go to, right, x ancestor? Can you go to 4 and 5? 4 and 3. So let's check. Those people are having little doubt also. You can see this. You can see this one time. I am at 5 now. How you came to 5? See this one. 3, 4, 5. I am at 5 now. 5 is articulation point or not? I want to check. Right? Now see correctly. After 5, I came to 6. I am at 6 now. From 6, any chance of going to? From 6, any chance of going to? Right? Either 4 or 3. Any chance of going to 4 or 3? Please verify. From 6, any chance of going to, is right, 5 ancestor. 5 ancestor is going to be 4 or 3. Yeah, you can go to 4. There is a back edge. So 5 is not a articulation point. 4 is not. 1 is not. 2 is not. So 3 and 6. If it is a leaf node, it's not articulation point. Leaf node means what? Only one person. If you delete that, no problem. So try to understand. So these are the rules. If root contain more than one child, then root is the articulation point. If x is not a root, if not root, these conditions should be satisfied. If leaf node cannot be articulation point. So third point. If you want, you can write. If leaf node, then it is not articulation point. Right? If leaf node, it is not articulation point. Because if you delete also, no problem. If you delete also, only one person, because only one line is there. If you delete, there is no problem. Right? These are the rules. Right? Now, I think all the people got clarity. So if you want, you can take. Yeah. Can you see one more example? One more nice example I want to explain to you. Can you see this also? So this is the graph. To this graph, I want to find out how many articulation points are there. I want to calculate. So I draw one DFT tree. Many DFT trees possible, but I draw one. One DFT tree I draw. Many DFT trees possible, one I draw. First of all, before going to proceed further, let's calculate how many articulation points manually. Is one is articulation point? If you delete one, together their incident edges. Graph disconnected? No. 1 no. 2 also no. What about 3? If you delete 3, together their edges. Graph become disconnected? I don't think so. What about 4? I think no. What about 5? I think no. What about 6? I think no. So no articulation point. Let's start one by one. Right? So first one. Is root is articulation point. See, one child. If root contain more than one child, then it's articulation point. In the DFT tree, if root contain more than one child, I think only one child, so it is not articulation point. Let's go to very, very important one. Let's go one by one. Is one is articulation point or not? First step. Are you root? No. If not root, assume that is x. Each child is y. Remember, this is a very, very important thing. So x child is y. I want to check is articulation point or not. Is child is y. Now what you do is from either y, listen, from either y either y or y sub 3. Remember the definition. From the y or y sub 3. Remember, y sub 3 means either y also will come, right? Y sub 3 also will come. From y or y sub 3, if you find out back edge to x ancestor. Back edge to x ancestor. X ancestor means back edge only. There is a back edge. There is a back edge. See, either from y or y sub 3, there is a back edge to x ancestor. Then this person is not a articulation point. Let's check. Let's check. Can you help me now? In this graph, if you observe 2 first, 1, I am at 4 now. From the 4 to 2, any back edge there? No. From the 4 to 2, there is no back edge. At least from 5 back edge there? No. At least from 6 back edge there? No. At least from 5 back edge there? No. Next one, 6 back edge there? No. Next one, right? Next one, 3. From 3 back edge there? Yes. See this one. From y or y sub 3, any back edge there. From 3, there is a back edge to 2. See, there is an edge going like this. Right? This edge actually. So because of that reason, back edge there means if you delete that person also, no problem. No problem. So that's the reason 1 is not articulation point. So please try to understand not only y sub 3 also. Those people who didn't get, can you see once again? Easy articulation point. I want to calculate 4 is the articulation point or not. 4 is the articulation point or not, I want to check. Are you root? No. So then it is a x. It is a y. Now see, can you help me now? From y or y sub 3, is there any edge going to x ancestor? X ancestor can be 2 also, 1 also, right? I think from 3 to 2 it's going. Yes. So it is not. Some people are asking, sir, what about 5, sir? Let's check. What about 5, sir? 5 is root? No. So same story. Is x, is y. From y or y sub 3, is there any back edge going to x ancestor? Ancestor means all these people will come. Yes. Right? Back edge there. So it is not a articulation point. So let's try the 6 also. 5 I completed. Let's go for 6 also. Are you root? No. Right. It is the x. This is the y. Right? From y to right x ancestor, is there any back edge? Yes. So is not a articulation point. Then what about y? Right? Everyone know leaf node cannot be articulation point. Leaf node cannot be articulation point. Because if you delete, there is no problem at all. If you delete, there is no problem at all. Try to understand. If you delete, there is no problem at all. Right? There is a reason for this. So I think I got to know that no articulation point. I hope you got. If you really like it, right? Please comment in the comment section. Sir, we got it. So you can do. So the purpose that means if you want to get the programming and all, first what you have to do is DFS program you write first. You want to write program for this one? DFS program you write first. Followed by how to find out backage. What is the criteria to go to the backage, right? How to find out backage also, please take care. Afterward, this is very simple. Simple backage to x ancestor, right? From the y or y sub 3, there is a backage going to x ancestor. If at all someone is not root in the DFT tree, if you want to verify his articulation point or not, assume that person x, his child is y. From the y or y sub 3, there is a backage going to x ancestor. Then that x is not a articulation point. Otherwise, articulation point. So please take care. So I hope you got it, right? Small doubts also there in the comment section. You can comment. I'm going to help you. Thanks everyone. Thank you so much.